You probably feel completely stationary right now. Your body isn't shifting, your chair is planted, and your environment is perfectly stable. But as you sit there, you are actually whipping through space at nearly 1,670 kilometers per hour. For centuries, scientists assumed motion was a simple, absolute binary. A rock, a cart, a person, they either moved or they didn't. But that physical sensation of rest is tricking you. To understand how movement actually operates, we have to stop trusting our immediate physical senses. Imagine you are sitting inside a passenger train, gliding smoothly at 100 kilometers per hour. You take a ball and toss it straight up into the air. From your seat, the result is entirely ordinary. The ball travels straight up, peaks, and falls straight back down into your hand. But someone standing outside on the platform sees something entirely different. They see that ball traveling forward at 100 kilometers per hour the entire time it moves up and down. Look at this diagram comparing the two perspectives. While you experience a straight vertical line, the observer outside sees a wide curved arc. The exact same ball is tracing two wildly different geometric paths at the exact same moment. Since a single object cannot physically trace two conflicting paths at once, the classical rule breaks down. Motion cannot be an absolute fixed property. We can see why this happens if we put a passenger in motion. Let's look at this train from the external perspective of the tracks. This diagram maps out the vectors. If the train is moving at 100 kilometers per hour and you walk forward inside it at 5 kilometers per hour, you only feel a walking pace. But to the ground outside, your speeds combine. You are moving at 105 kilometers per hour. Now let's update the math. Turn around and walk toward the back of the train at that same 5 kilometers per hour. To you, you are moving backward. To the ground, you're still moving forward at 95 kilometers per hour. This proves that movement only exists relative to a specific boundary. Inside your boundary, your reference frame, is the train itself. Outside the reference frame is the ground. Both reference frames give mathematically precise answers, yet those answers contradict each other, which means asking for the single true speed of the passenger is a nonsense question. We can scale this up to see absolute speed collapse. Think of a passenger sitting inside a commercial jet cruising at 900 kilometers per hour. Relative to their seat, their speed is 0. Relative to the surface of the Earth below, they are traveling at 900 kilometers per hour. But the Earth itself is spinning at 1,670 kilometers per hour and orbiting the Sun at roughly 107,000 kilometers per hour. 0, 900, or 107,000 kilometers per hour. We have three vastly different measurements for the exact same person sitting in the exact same chair. Which one is correct? All of them. Because speed is not a physical characteristic that an object possesses. It is strictly a value assigned by an observer based entirely on where they are standing. If speed is just a matter of perspective, we hit a serious problem. When a car slams on the gas, you are thrown back into your seat. Objects fall straight down, not sideways. We feel actual physical forces. To explain this, scientists reasoned there had to be a universal background frame that was completely still, an invisible medium they called the ether. If they could measure against that, they could finally find true, absolute motion. They designed incredibly precise experiments, firing beams of light in different directions to catch the drag of the Earth pushing through this invisible cosmic grid. But the instruments detected absolutely nothing. No drag, no grid, no universal stillness. The ether did not exist. Without a universal background, physics had to abandon the concept of a fixed frame entirely. Space was not a static stage, and everything inside it was strictly moving relative to everything else. Let's bring this back to the train. Inside that cabin, as long as the train is gliding at a constant speed, water stays perfectly flat in a glass. The physics behaves exactly as it would if the train were parked. There is no physical experiment you can run inside a closed, smooth-moving system that will tell you whether you are moving or at rest. Looking at this combined diagram, we can see the tossed ball was never tracing two different paths. It was tracing a single path, captured by two different observers who both lacked the complete picture. This single rule governs all movement everywhere, from cars passing on a highway to planets orbiting stars, to entire galaxies spiraling through the void. You feel stationary right now, not because you are actually still. You feel stationary because you, your chair, and the room around you are all moving at the exact same speed. Stillness is just what we call it when two reference frames match.